My name is Laura Ballerini. I'm a researcher and neuroscientist from the University of Trieste. Recently, I've been moving towards research areas which imply an interdisciplinary approach to neuroscience, which involve materials, nanotechnology, and nanodevices in general. We put together carbon nanotubes, which are a novel form of carbon made of raw layer of graphite, and neurons. In this case, we build up the hybrids by letting neurons grow on these materials. And we find out that neurons behave in a synergistic way with the materials and get instructions, biological instruction, from artificial materials, and at the very end, neurons usually improve their performance. One goal is towards healthcare, that is regaining lost functions in terms of disconnected neuronal networks, as is the case of spinal injury, for example, spinal cord injury, and to regain motor control by providing an interface and a sort of interface between brain and spinal cord, or neuron-neuron interface, that is neuron, material, neuron. On the other hand, I belong to basic neuroscience. Therefore, for me, another aim is to investigate mechanisms, molecular mechanisms, as I mentioned, languages, how an artificial material, by physical and chemical property, instruct a biological behavior.
My name is Giacomo Bonetti. I'm a second-year PhD student in Professor Ballerini's laboratory. I work on spinal explants, spinal network explants. And on these explants, I record the electrical activity. At the same time, I stimulate the network itself with particular type of electrical stimulation. I call them exotic stimulation because they have a particular origin and particular properties. The fact is that the signals I use, the simulations I use, are biological in origin, and so they display waveforms which are radically different from those used in neurophysiology most of the time. That is, that they're not trains of square pulses. They're not perfect, they have noise on themselves. What I'm doing is taking a biological signal which is more or less a motor output and feeding it back into the system, into spinal motor networks. And what happens is actually interesting, because we take a biological signal from more or less the same source and feed it back into the system, and we see that the activity improves. The events are much more frequent. Patients with spinal injury can regain a degree of motility using stimulators on their spinal cord. But they have side effects, such as neuropathic pain, which could be avoided by implementing the type of stimulation that I use, because the intensity that they need is much lower than that used by the present type of stimulators.